This video is the continuation of the circuit breaker series. Until now, we have implemented the core functionality of the circuit breaker, which is to open and close the circuit based on the thresholds configured. Now, I would like to add two more functionalities. First is to detect any change in the circuit, and second, it's the ability to manually change the circuit breaker state rather than waiting for the threshold values to exceed the limits. So let's get started with the first feature. So I'll start with a Pojo CB listener event. This Pojo will contain all the details regarding the circuit breaker. So let's click on new, add a class. I'm creating this Pojo in the internal package. I'll name this as CB listener event. All right, let's hit finish. Okay, now I'll add couple of member variables. So first one would be the circuit breaker ID. So let me create a private member, private string circuit breaker ID, and then I'll add a variable called CB state. So this is an enum that we have already created while creating the core functionality of the circuit breaker. So one will be the old state and the other one will be the updated state. So let's create the CB state, updated state. Okay, there's a typo. Let me correct this. All right. So now it's time to create getters and setters. Alt Shift S. Generate getters and setters. Select all. Okay. And I would also like to have a constructor, a public constructor, which will which can initialize the object listener event, and then I'll add all the required values: string circuit breaker ID and old state and the updated state. All right, and then I'll assign this values to the member variables. Circuit breaker ID equals to circuit breaker ID old state this dot is to updated state. Okay, so this Pojo will have all the details regarding the state change. So it will have the circuit breaker ID, old state, I mean the state which was before the state was changed to the updated state, and the updated state. Okay, so now that we have this Pojo, we now need to create another class which can utilize this Pojo. Okay, so basically now we are looking to create a listener. So let's create another class in the same package. Click on new. I'll create a class and I'll name this class as CB listener. And this will be a listener. It will be a normal listener, typically like an HTTP listener, AMQP listener. So of that sort. So it's a source component. Okay. So I have this class created. Now to make this as a source component or to make it as a listener, I'll need to extend it to a source. So how do I do that? I do extends, then there's a class source, and source can take in generics. So before that, let me do an import for this source. So for some reason, I guess it's not automatically showing us. So let's add the generics manually. So source will have will can take in two generics. One is the payload and the other one is the attributes. Okay, so for this we don't have any attributes. We just have the payload which will be stored in the cb listener event.java. So I'll pass cb listener event listener event, and we don't have any attributes, so we make it as void. So this is the source. Now let's see if we get an import. Yeah, so we do get two possible imports. So one is from Mule runtime extension API and the other one is from Scala. So we need the first one. So let's import this. Okay, so we have extended. Now we need to implement the missing method. So this is possibly an abstract class source, if you see, and we need to implement the unimplemented method. So just click on add unimplemented methods. So there are two methods. One is the on start, the other one is on stop. So on start method will be automatically invoked by the Mule runtime when it's starting. So whenever it starts, there will be multiple flows in your application, and if a flow is having a source element, it also has to be started so that it starts producing messages, right? So this thing would be done by the onStart method. An onStop method is when you stop the flow, or for that matter, you can also stop the application. So the onStop method will be called by the runtime. And in this case, you can possibly release all the connections or the resources that you have been using for a graceful shutdown of your application or a graceful stop of the particular flow. So you have to provide your own implementation of both the methods. So now let's implement this method. So the IDE has automatically given me the signature. So on start gives a method called as source callback, and the source callback will now have the listener event, and attributes will be void. So I've made it as void, and it throws mule exception by default in case if you want to handle that exception that your application can throw. You can always do that, but right now let's keep it as default. So in case if you want to handle exception and do some custom work, you can always do in this way. So if you observe this document, it says that this method should throw an exception if the source fails to start, so which will already be done by this, but any other exception encountered during the process for generating message, it should be communicated to the runtime through this method on connect exception. So we'll keep it quite simple. We are not interested in handling those because we will not encounter here. Okay. So now let's implement this method. So the idea is that a state change will occur on the shared memory, which is backed by Hazelcast, and that has to be detected, right? So now what we would do is we have to first get the instance of replicated map. So in case if this is not making you any sense, what I'm talking about the replicated map, I would recommend you to watch the previous videos. I think it's a series of 5 to 6 videos which has details of how did we implement this circuit breaker. So now If you're aware of the previous videos, let's start with I already have a CB cluster service, and this service can return me the service instance. So get service instance. So I'll get a CB cluster service. I get the instance. Then I want to get the CB state map. So I get the replicated map. Now in this map, we'll have the details of all the circuit breaker IDs and their respective states. Now what I want to do is I want to add a listener to this map so that if there is any entry which is getting either created or if it's getting updated, I want me to be notified. Okay, I want Hazelcast to notify my application. So what I can do is I can add a listener to this. So add entry listener. This is the method that we have to use. Now to this method, I would need to add an argument, okay, which can help me to detect the state changes, and then I would want to do some activity, right? So I'll have to add an implementation inside this method. I'll have to pass an argument, okay, which tells what to do next in case of any entries added in the replicated map. So what I can do is we have a method from Hazelcast which is known as adapter entry adapter, okay, and that entry adapter helps us to achieve this thing. So what I can do is I'll give an anonymous implementation for this entry adapter, okay. So I'll create oh, a new entry. Okay, for some reason this control space is not working. Okay, so here it is, entry adapter. So entry adapter will again it's generic. So what I can do is I'll give string and the CB state. So it will have basically it will have the ID and the state of the circuit breaker. And now let me just give an implementation. Let's see if we get some. Okay, we are not getting. So what I'll do, there are two methods that I can override. Okay, which is one is the entry added and the other one is entry updated. So let's write those two methods. Public void entry added and some implementation to it. But again, it should take argument, so which is an entry event. So string and CB state, and this is the event. So I'll use this event, and again let me create another method which is entry updated. Okay, so entry updated. Okay, okay. So we now have two methods, and we need to write some line of code that can handle the activity that tells what activity has to be performed. So let me just add an annotation. So we are trying to override this as well as the other method, which is updated. Okay, there's some compile time error. Let me add a semicolon and should be gone. Okay, now again we have some compile time error here. So entry event is import is missing. So let this import, and now it's working fine. So no compile time errors as such. Okay, so now that we have done this, now we need to create another method, okay, which can perform some activity. So what I'll do is I'll name that method as private void handle state change. So this method is responsible to handle the state change. So if there is a new entry added in the replicated map or updated in the replicated map, this method will do its task. So basically what this method has to do is send the message back to the runtime. So initially, whenever the Mule runtime will start, it will call the onStart method, and the onStart method will run this few lines of code. So basically, it will add a entry listener to the circuit breaker. Once that is added, every time a new entry is added or updated in the replicated map, these two methods will be called, entry added and entry updated. And once they are called, I'll internally call the handle state change. And this method is responsible to send the message back to runtime from source to the flow. It will send all the message back to the runtime with the payload and the attribute. So what all arguments do I need? So I need a source callback because this message will be sent to the flow. So I'll add a source callback, and again it's generic. So I'll add CB listener event. So this event Pojo will contain all the details. So it will be part of payload, and I don't have any attributes. So let's keep it as empty, and let's name this as source call callback. And let's take another uh, argument, which is event entry event. So entry event, which we created in the previous methods. So this entry event will have the ID and the CB state. Okay, so let's implement this method now. So what are we supposed to do here? So we take the state from the event that has been generated. So what I'll do is final CB state, and it will have the new value. Okay, so from this event, okay, from this event which was created, so this event will come over here and we'll pass it over here. Okay, so whenever the circuit breaker state is changing, right, so this will give me the ID and the state. Okay, so what I can do is event dot get value. Okay, so this will give me the updated value, and then let's do a source callback. So I'll use this source callback and then call handle method. Okay, and handle method. And now in this, I'll have to pass the result. So I'll use result dot CB listener and void. I'll use a builder method on this result. So let's call builder. Okay, and then again I'll use the output method. It's not showing up. Let me import result first of all. So result. So this result has to come from the Mule runtime. So this the last one that we see. This is the one that we need result, and then we have the static method builder, and then on this builder has an output method. Okay, now in this output, I can pass the listener event. So I want to pass this object listener event, and I'll not just simply pass it, but I'll have to initialize it. Okay, so to make things clear, what I can do is I make this CB listener event. Okay, CBE, something like this. And then what I'll do is I'll create a new object for this. So new CB listener event. And now it takes the we don't have a default constructor, but we have our own custom constructor, right? So it will take a couple of arguments. So if I do control space, it's complaining me that I need to pass all these arguments, right? So if I double click on it, it says add argument. Okay, so first argument is the circuit breaker ID. Okay, so using this event, I can get the ID. So what I'll do is event dot get key. So key will be the circuit breaker ID. Then I will have event event dot okay event dot get old value. Okay, and this will be the new value. So this is what it is, right? Uh, so old state and the updated state. Okay, so the we already have our updated state in this value, and older value will be retrieved from event.getOldValue. So rather than creating this, I can simply add this over here. Okay, so let's get rid of this. Okay, now we are sending this object output. But one thing we are missing is we have to build this event. Okay, so we use the dot build method, and I hope the compile time error should go away. It's still not gone. Okay, all right. So it says that the method output CB listener in the type result.builder is not applicable for CB listener event. Okay, so it's not applicable because the listener, this result, the builder type should be listener event and not this class listener, right? So that is what it's complaining of. It says that here I'm passing listener, but in output I am passing listener event. So this has to be same. So I make it as event. So now it should stop complaining. Okay. All right. So this is completed now. Let's see what is never used locally. Okay, so it's complaining that it's okay, it's warning, not an error, but yeah, it's fair enough that it's complaining that we created this method, but we are not using it anywhere. So time to use this method. So what I can do is uh, now I'll use this method. So that is the whole purpose of creating this, right? So whenever this entry is added or the entry is updated, we call this method. So I'll call handle state change. Handle state change, pass source callback and the event. Same is applicable for this method. Now, optionally, we can add loggers. So we need to add, let's just add loggers so that it helps us to debug. So I've added a logger and a couple of details whenever, so in the first attempt when the runtime starts up, so this log will get printed when the source is initialized, and upon every new entry addition or update, this logs will be printed. So this is enough for the listener to work. Now, since we are not opening any new resources, it's okay if we keep this empty, or instead we can simply add a logger.info Uh, so CB listener stopped, something like this. We can add CB listener stopped. So this should be enough. Now, one important thing that we need to do is we need to register this listener, which is missing. Without that, it won't work. Okay, so what we can do is we have a configuration service, and here we have registered the operations. Okay, now we need to register a source. So add a source annotation, sources. This is the annotation, and I can give the name of that class, which is CB listener dot class. Okay, so this is done. Now, what I would like to do is I can give an alias to this class. So, so this alias will be the name that appears in the Mule palette. Okay, so let me give alias as CB listener. Okay, so with that, the listener part is complete. So just to uh, revise, what we have done is we first created a Pojo, which is CB listener event, which had all the details related to the circuit breaker like ID, old state, and updated state. I created a constructor so that this object can be initialized. Okay, then I have a CB listener class, which is basically the source. With the help of this class, we can create a listener. Okay, so how do we do that? We extend this to source, and that source can take generic. Okay, so it takes a payload and attributes. So payload is CB listener event, and attributes are void because we don't have any. Then since this is an abstract class, we had to override two methods, onStart and onStop. These are called by the runtime, so we don't call this, runtime calls it. And whatever implementation we are giving inside this class will be called by runtime. So now our main objective was to detect the state changes. So state changes are basically stored in the replicated map that we are using. So that is what we are doing. We are getting the instance of the Hazelcast, then we are getting the replicated map instance, and then we are adding an entry listener to that map. So this entry listener would call a few methods, okay, whenever there is any state change in the map. So state change basically means addition of new entry or update to an existing entry. So in that scenario, we can use an entry adapter, and this entry adapter is again generic. So we give the circuit breaker ID and the circuit breaker state. So we have again overridden two methods, entry added and entry update. So this whole part belongs to Hazelcast. This has got nothing to do with the Mule runtime. Okay, so this is a custom logic over here. So whenever if there is a new entry added, it calls the handle state change. Also, when there is any entry updated, it calls a state change. And what is a state change method doing? It's just initializing the CB listener event Pojo with old values and the new values and the CB ID. Once it does that, we create a result object and we send that result object to the handle method, which is provided by the source callback. Now this source callback is already available to us from the Mule runtime. So once we call the sourceback.handle, the message goes back to the runtime for further processing. So the source has done its job of producing the Mule message and sending it to the flow. So whatever the processes are there, they can do whatever they want with the Mule message. So we converted that Hazelcast event into a Mule event using this particular source. So now with this, the implementation part was over. and then we had to register this. So we have done by adding a sources annotation with the name as cb listener dot class to the cb configuration service. Okay, so now we have to create the second, we have to implement the second functionality, which is to be able to manually change the circuit breaker state rather than waiting for the threshold uh, to be reached, right? So let's start with that. Now, the second functionality is quite simple. To create that, we go to the operations class and we just have to add a public method so that it becomes a connector. So any public method which is present in this operations class becomes a uh, connector. Okay, so I'm not doing much over here. This connector will have two values. Okay, one is the circuit breaker ID, which is of type string, and the state, which is an enum. Okay, and based on whatever values we have, we can call the cluster service, and the service has a helper method to change the circuit breaker state, which we created previously. We just pass the ID and state. So we have all these methods created. Let me add a display name as well to this and make it as uh, change CB state. Save it. Okay. So now it's time for us to increment the POM version and then uh, do a maven clean install and check it out. So I've opened the folder location where this project is placed. Now I'll do a maven clean install. So the build is success. Now it's time to implement this in a Mule application. So let's try that out. So let's go back to Studio. And here's this app that I tried out last time for the circuit breaker. And if I observe, the circuit breaker version is at 1.0.0. Let's go to the POM file, increment the minor version. Actually, it should have been a minor version increment, but we incremented the patch version, but that's fine. We are not worried about the conventions. Okay, so make it as 1.0.1. It should be now available in the class path. So I do see 1.0.1. Let's go to the configuration file, the Mule palette. Let's see if I have. Okay, I have two operations, uh, change CB state and the CB listener. Let's try to drag and drop. So I'm not sure why does it show in operation, but that's fine. It's pointing to the listener only. So the listener is already available. Now we don't need to configure anything for this. Uh, if the Hazelcast instance is already configured using this config, this should be fine. What we can do is we can add a logger and print the payload. So output application JSON. And this remains the same. So will it generate some error? If it generates some error, then we can automatically see the state changes, right? So most likely it will generate errors. So let me try to run it and see if it works. So the application is now deployed, and if we observe the logs, we have the same old logs wherein it's initializing the Hazelcast cluster and the members joining the group. Now, at this point of time, we just have one member, so this is expected. Now, one main log that we need to observe is the one that is created for the listener. So if we scroll down when the app is completely deployed, we should be able to see this log. So if you see, this is the CB listener log saying starting circuit breaker listener. So it started the circuit breaker listener. Now it's time that we trigger the endpoint. So let's check the endpoint. So there's no path, the default, and port is 8081. So let's try to hit this. Okay, let's go to Postman and send a request. So I do see an error that has occurred. So 404 is the error that we got. Now let's go back to the console and observe the logs. So we do see some logs coming up. Okay, and so it initialized the partition because now the state change happened. Okay, and uh, initially the state was null. Then when the first transaction went in, it updated the state to closed. So this is a mule log which is being retrieved by the CB listener. So you see this, right? It's from the logger message processor. So initially it was null, circuit breaker ID was CB demo apps and updated state to closed. And again, when the error occurred, uh, the state was updated to error. So this means that circuit breaker is working as expected. And again, after the threshold was completed, threshold duration was met and the condition for trip was satisfied, we see that the updated state is now in open. Okay, so which means that the circuit breaker listener is working as expected. Now that we were able to test the CB listener, it's time that we test the state change. So I've already dragged and dropped the state change connector. I'll have to give the ID. So I want this app to be tripped. Okay, so I can give this ID or use app.name, whatever is comfortable. State, let me select it as, what do I select it as? Select as open. Yeah, let me select as open and save this. So it should get redeployed. Let's wait for it. I think it's not redeploying automatically. So let me run this project again. Yes. Okay, so we redeployed the application. Now I have to call the other endpoint to change the state. So it is state change. So let me go back to Postman and let's see what happens. Okay, I got a 200 response. Now let's go back to the studio and see what has happened. Let's go to the console and I do see the state has been changed to open, which means that the functionality is working fine. Now, since the state is open, now it would never go back to the closed state automatically because we changed it manually, right? So there is no scheduler activity getting triggered. So now if someone wants to uh, correct the state, so basically they'll have to use the same connector to change the state to closed or error, whatever it is. So basically you would change to closed, right? So just use the connector. So make it configurable rather than having oh, there's a drop down because we use enum, but this can also be made configurable by going to this XML and changing the value. So that should help. So that was it for this video. So this video should give you a not just from the circuit breaker perspective, but from a generic perspective of creating custom connector. This video is the best point for you to understand how the sources work, and you can create your own listeners as well. One point that was not covered in this was the emits response, because this connector does not send any response back to the client, right? It's just a listener. You cannot call this on your own. This automatically gets triggered by the Hazelcast instance. So it's a listener, that something that cannot be consumed by the client. So I didn't use the emits response, but that's another thing that you can use when your listener responds back. For example, the HTTP listener. So I hope you might have found the video useful. Thanks for watching.